Jeff, we're at the FQXI conference looking at the nature of events. What happens in physics? It sounds very simplistic, but when you understand events in quantum physics, it gets very sophisticated. What can we learn about the nature of time by studying the nature of events in quantum physics?
I'll try to maybe give a slight slant to what's new that we can say. The old story really came from the beginnings of quantum mechanics and Einstein and relativity. In essence, Einstein, by discovering relativity, he did away with the whole notion of an absolute now. So the notion of a now was a relative thing. It depended on the relative motions between observers, so on and so forth. And Einstein commented that one of the biggest mysteries to him was the fact that we have this subjective experience of time, this becoming experience, which as a matter of principle could never be part of our objective structure of nature. And so Einstein went so far as to write the widow of a friend of his when this friend passed away, and he wrote, Michel, he's still there, right? He hasn't really died. He's part of this, what was called a block universe. All those moments of time in the past are still there. They're equally as real as we are right now. So that's kind of taking that view to the extreme. So the second thing is you say events. And what does that mean? Well, there's the old notion of events are just sort of points, like a precise mathematical idealistic point in space.
And time.
And time, but that's the next thing. The next thing is what I understand an event to be is kind of more like process. And so if you can say that an event is something that's spread over space and time, that's more like a process kind of way of thinking about it. We've done a lot of work on that kind of thing. So we look at the underpinnings of the basic elements of quantum reality that we can see. And so we've invented ways of observing events, processes, in a fundamental sense, which suggests that you could have, say, one particle, and you could observe it in a way so that it's not really here in time or there in time, but only when you look at both times together is there a particle there. If you look at there, it's nothing there. If you look at there, nothing there. But when you look at both times, there's something there. And that sort of expands the notion of a thing into at least 2 points in time.
So what that says overtly is that unless it has two separate points in time, it doesn't exist. That's what you said. Now
that's right.
That doesn't seem to make sense.
There's no operational meaning to say that the particle is at this moment in time or the particle is in that moment of time. Its state exists, for example, at two different moments in time only. And it doesn't break down into one moment plus another moment. So we see all kinds of states like that. And the reason that's important is because we started to ask deeper questions about the nature of time. For example, just as a curiosity, I was wondering if the old notion of time by Heraclides, you remember, this is thousands of years ago, Heraclides says, you never step twice into the same river. And so to me, that seemed like a very different notion of time. I mean, the kind of time notions and concepts that we've grown up with are very different. They suggest that we have individual objects in the universe, and they just change their state in time, and then the next time they're the same thing, but just maybe change their state in time. Heraclides seemed to suggest that each moment is like the whole universe is born new. Yeah. It's completely new. We think we're the same person, but we're born again. And I was curious if physics could accommodate this. Turns out it can't. It's not possible for physics to make a picture of this unless you have a picture of this process, of these events that are spread in time. If you allow for that kind of a physics, then you can paint such a picture.
How does one affect the other? If you have the two particles that only exist when you have them at 2 points in time, how does that affect this sort of macroscopic understanding of the nature of time?
So it turns out that if you want to have a picture in which the universe keeps getting reborn again and every moment, then it turns out that the only way to connect these universes together, like the universe at one moment of time with the universe at the next moment of time, is to have one of these process-like things that is spread in time. So we have, I don't know if I can do it with my fingers here, but you have here's one moment of time, here's another moment of time. You have to have a processing that can connect those two universes. Otherwise, it's like a barrier of lead between them. But those process event type things can connect them.
And so that each one of those is like a point in time, and so it keeps recreating itself.
It keeps recreating. And the thing that makes you think that you're the same person, right, is this process thing, which connects the you from the previous universe to the you in the next universe. And it sort of passes the you along. So you're always new, right? It's a beautiful idea. And it actually led to so many beautiful new mathematics and ways of thinking about the deep physics that it even let us solve or develop a picture. I don't know if it's the final answer, but it even let us solve a picture for our notion of becoming, our subjective becoming, the thing that Einstein said nobody would ever be able to do. So we were able to have our cake and eat it. We were able to make Einstein happy because we had this each moment of time as a universe is this, is like his big block universe, but we also were able to have a subjective becoming.